The brilliant mind of the week is Claudius Ptolemy. Ptolemy's mathematical developments and life history are truly remarkable. Claudius Ptolemy, who lived from around 100 to 170 CE, was one of antiquity's most influential mathematicians and astronomers. He worked primarily in Alexandria, Egypt during the Roman period. The city of Alexandria was then a major intellectual center, home to the famous Library of Alexandria, where scholars had access to an unprecedented collection of knowledge. Mathematical developments. Trigonometry. Ptolemy created the first detailed trigonometric tables known as the chord table. In his masterwork, the Almagest, he developed fundamental trigonometric functions, particularly for spherical trigonometry. His chord function is related to our modern sine function by the formula. He calculated chord values for angles in increments of half a degree from 0 degrees to 180 degrees, achieving remarkable accuracy. Geometrical theorems. Ptolemy developed Ptolemy's theorem for cyclic quadrilaterals, which states that for a cyclic quadrilateral ABCD, AC times BD equals AB times CD plus BC times AD. This theorem became fundamental in later mathematical developments and is still used in modern geometry. He also created methods for calculating square roots and cube roots using geometric constructions. Astronomical mathematics. Ptolemy developed complex mathematical models to predict planetary positions. He created a sophisticated system of epicycles and deferents using circular motion. Additionally, he invented the equant point, a mathematical concept that helped explain planetary motion. His mathematical model could predict planetary positions with remarkable accuracy for his time. Ptolemy was born in Ptolemais Hermiou in Upper Egypt around 100 CE. He received his education in Alexandria, which was then under Roman rule. It's likely that he studied at the Museum of Alexandria, though details of his early life are sparse. Ptolemy conducted most of his astronomical observations between 127 and 141 CE. He worked primarily in Alexandria, continuing the Greek scientific tradition. He had access to centuries of Babylonian and Greek astronomical observations. Ptolemy wrote in Greek even though he was a Roman citizen. Major works. The Almagest, originally titled Mathematical Syntaxis, is his most significant mathematical and astronomical work. It consists of 13 books that combine mathematical theory with observational astronomy. This work remained the primary astronomical text for nearly 1,500 years. Geography. Ptolemy applied mathematical principles to cartography. He developed systems of latitude and longitude and created projection methods for mapping the spherical Earth onto a flat surface. Legacy and modern applications. Ptolemy's work in spherical trigonometry has had a lasting impact on navigation, both maritime and aerospace, modern astronomy and celestial mechanics, geodesy and cartography, GPS technology, great circle calculations for aviation. His sexagesimal system is still used in modern time measurement, such as hours, minutes and seconds, as well as in angular measurement, astronomical calculations and navigation systems. The influence of these developments continues today in various fields. Mathematical education. Spherical trigonometry remains part of advanced mathematics curricula and serves as a foundation for non-Euclidean geometry, differential geometry, and modern astronomical calculations. Scientific applications. Ptolemy's methods are used in space, navigation, satellite positioning, global positioning systems, astronomical calculations, and geodetic surveys. Technical fields. His contributions are evident in aviation route planning, maritime navigation, land surveying, architectural calculations for domed structures, and climate modeling. These contributions demonstrate Ptolemy's genius in developing practical mathematical tools that remained useful for centuries and continue influencing modern mathematical and scientific practices. The endurance of Ptolemy's mathematical work speaks to its sophistication and utility. While his geocentric model of the universe was eventually superseded, many of his mathematical methods and theorems remain valid and useful in modern mathematics. His approach to systematic mathematical analysis and documentation set standards that influenced scientific methodology for centuries. Thank you for watching. Source: for further scholarship on Ptolemy, I'd recommend consulting academic databases like JSTOR or Project Muse, modern mathematical history journals, university library collections specializing in ancient mathematics, and recent scholarly editions and translations of Ptolemy's works.